Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome again to another episode of the Smart City podcast. Today I'm thrilled to be joined by Greg Boucaud of universalautomation.org. Welcome, Greg.
Hey.
How are you today?
Yeah, doing good, thanks.
All right, you enjoying the 27th annual ARC conference?
I am enjoying. It's the second time we are here on this conference, so we are quite happy to be here. Come all the way from Europe to join this conference, so more than happy to be here.
That's superb. Greg, can you tell us a little bit perhaps about yourself and how you came to join universalautomation.org and the essence of your organization?
Yeah, so as you rightly said, my name is Greg Boucaud. I'm the Chief Marketing Officer for universalautomation.org. I have been already 10 years in the automation market, mostly in the marketing position and working for some of the leaders in the industry like Schneider Electric. And I've joined this organization no longer than 1.5 years ago when the association was created. And so universalautomation.org, maybe what it is, some few words about it. It's a non-profit association which has been created in November 2021. It's based out of Belgium, Brussels to be more correct. And the goal of this association and the vision is to decouple the hardware from the software in the automation realm. So today, when you program your automation architecture, you tend to program by using one brand. So let's say Schneider, Siemens, Rockwell, whatever brand you want to take. And that application that you have programmed is today locked with that brand. So if you program with one brand, for example, with Rockwell, for example, you're not able to take that application and just have it run on another platform from another supplier. When you have a look at the IT space, you see that on your laptop, when you want to install the software, for example, on Windows laptop, you don't look at the brand of the laptop, you just install your software. And that is not what is happening in the automation market, and that is what we want to change with Universal Automation. So 1.5 years ago, 9 founding members from both the vendor group, so vendor of technologies, from the user group, so end user, system integrator, OEM, process OEM, universities and startup, grouped together to create this universalautomation.org. So universalautomation.org is quasi the realization of the concept of universal automation, which is one step further than just open automation, and which is based on the IEC 64099 standard. So the IEC 64099 standard, it's just, let's say, the next development and the next achievement after the 61141 was made by most of the same people which let's say, specify the 61141, which is mostly used today on the automation market. And what it does and adds is the decoupling of the hardware and software directly within the standard. So this is the base of our technology.
Okay, so we understand, and particularly for our audience who may not be well versed in this in this domain, I think we all understand that example about a Windows machine, and we load an application and it runs. We don't care where or even its form factor. It could be a desktop, it could be a laptop, it could be something else. But in that scenario, we do have one private vendor that has an operating system. Yep. Microsoft owns Windows.
Yeah.
Do you envision universalautomation.org, the results to go down that path where there is one operating system that's shared across those platforms, or is it more true to the vision?
In fact, it comes to the explanation how does universal automation decouple really the hardware from the software.
I'll just quickly interrupt that. Not sure everyone knows those two IEC standards, so maybe you want to start with describing those a little bit, if you could. That might be a good foundational start.
I could. So the IEC 61131 is the mostly used standard today in the automation space. So it's a scan-based system. You do your automation based on scanning. You mostly use, let's say, a centralized approach. You have one PLC, so one controller for your automation. You program it, and you have your let's say, program running on a scan-based basis. So easy. Every few milliseconds, you launch an order and you do something.
Right.
So that's 61131. 61499. Now it's not scan-based but event-based. So the same as what you see in the IT, when you have an event happening, you do something. So it's like, okay, if, for example, you are in a plane, you are waiting to take off. Example for 61141 is like you ask every 10 seconds to your control tower, can I go on? Can I take off? Can I go on? Can I go on? Can I go on? 61499 is like, okay, I just wait for the tower to give me the red signal, and when they give it, I just go. So that's different between event-based and scan-based system. So I think just to give a few ideas of
that was a great explanation. So thank you for that. Next, now that we've established that foundation, continue on, please, with the vision of universalautomation.org.
Yeah, and
the
come back
decoupling.
to and the decoupling. So the way it does that is that the universal automation uses what we call a reference implementation. So it's a software piece that you can put into a controller, and this software piece is shared amongst members, so vendor members. So whatever product that you buy from a member of the association will have in the future this piece of software onto it. And this piece of software is helping you as a user to decouple your application from the software it runs on. So we are not really an operating system, because you can compare it to the operating system like Android, like Windows, like Linux. But this piece of software sits on the operating system which already exists. So it could be today, in controller space, we use mainly Linux, we use VxWorks, we can use sometimes Windows for some IPC based, and this piece of software sits on that. And does mainly the translation between your program, what you have programmed, and let's say the hardware architecture and the controller itself. So that's the runtime.
Okay, so it gives you a standardized API at the higher level.
Yeah.
And at the low level, it mates to the particularities of each processor and firmware in that controller.
Yeah, we could say that simplified in this way. We could say that knowing that you can have different engineering tools interacting with that runtime. So that's not an issue today. And another thing, and it's as well another way of working the automation industry, is that this idea of reference implementation comes from the IT industry. So, for example, Linux. Today, when you want to use Linux on your PC, you not just go to the Linux, let's say, download the specs and develop your own Linux, but you take Ubuntu, Debian, or whatever version of Linux. Those versions are so-called as well reference implementation. So it's the same that we are doing in the automation space. So you have the standard, the 61499, and then you have the UAO runtime, which is like the Ubuntu for the Linux in an easy way.
Do you see people having a need to modify that runtime implementation, or will they take it out of the box and use it as is?
So the idea and what we are doing within Universal Automation is that this runtime is using a shared source approach. So there is one common code which is shared amongst members, and there is no need to modify it. And even the association is there to guarantee the portability of the application. And in order to guarantee this portability, we need to ensure that the code is the same amongst all members. But today, to get access to this runtime, that's for any vendor, that's quite easy. They apply to the organization, they become a member, and they get access to the runtime so that they can use it as is into their own platform. The next thing is, and it comes to your question about Windows, this runtime will be further developed and maintained by the organization and by its members. So when you become a member, you have a say on where the runtime is going and where the next implementation will be. And that's a major thing as well. It's really, you have to see it as a very collaborative approach. That's a platformy approach amongst members and especially vendors of automation.
I say it's community driven,
yes,
rather than any private supplier driven.
And again, we are a non-profit association, so our goal is not to make money out of it.
Right. So then let me put on my hat as the let me ask the question this way. So I have now an application that I would like to run in my controller. But I do want to take advantage of these advances that Universal Automation has done.
Yeah.
So I load my Universal Automation middleware, let's call it.
Yeah.
Or how
you will have to, so you cannot really load it as a user of automation.
Right.
You have to do multiple things. You have to first program your automation. So you have an automation, let's say, situation. You need to program
my logic,
automation
my
solution.
control logic.
Yeah.
Right. Okay.
You need to have an IDE, engineering tool, to do it. So for that, you go to the vendors and you see which vendor has a engineering tool to do it. For example, the one which is mostly used today is the one from Schneider Electric, which is called EcoStructure Automation Expert. So you go, for example, to Schneider, you buy this EcoStructure Automation Expert, and you can build your own logic. This logic, in the way you build it as well, is a bit different from the way we do automation today. So this logic is quite object-oriented, so you can really draw your assets and define them, and behind you have an idea of a state machine, which in terms of states gives you which algorithm you have to use. Then you plug them all together and you really map your full machine, your full process, whatever you need to automatize, basically. And then the next step is you assign which device you need to run your automation logic onto. Could be one device, could be multiple devices. Those devices are, let's say, defined by the fact that they have the runtime onto it. So you have a list of devices which are available to you. You go to the member of the association. Okay, now we have launched last year 5 offers with the members, which are available. So 6 with the one of Schneider Electric. You can take any of these devices to answer to your automation, let's say, situation, and then you just map. You take part of your program, you say, okay, this part we run on this device, the next part we run on the next device. So it makes it really easy to scale it. So if at some point you need to change, let's say, add a module, it's very easy. You add the module to your engineering tool, and then you map it to the device, to the one device or the multiple devices which are available to you. But you don't have to think about, okay, what are the connections between the devices and all of that. You really start from the engineering, from the program, and after you come to the hardware.
I see this. I see the strength of that. The essence of my question, what was in my head, was thinking about the support of legacy code that may exist in the plethora of PLCs and controllers that are in the field. Is there support for legacy applications, or do I need to code a state language logic set from scratch myself?
For legacy, there are multiple things to do. It's either you want to rip and replace, and then you have to really take the code but rewrite it anyway. And it's an effort that you have to do, but take into account if you have a change in generation of the controller, for example, you will have this effort to have, because even if you stick with the same supplier, you will have to redo the code anyway. So that's the same effort. But there are some situations where you have a running machine, running plant, running process, which comes to you, and you want to upgrade it. So keep the most of what's already existing, but add some functionalities to it. And there's this possibility with the runtime. So you buy a product, and this product sits on top of your existing automation plans, process, whatever, does the orchestration to it, and can add as well some IT connectivity. So if, for example, if you need to connect your digital twin, if you need to connect to your SAP system, MES system, or whatever IT system, you could do it with having still your legacy, let's say, still running under it. So really the strength of that is, and this is why, in fact, we've done it at the beginning, we've seen that users, they need to, let's say, become more flexible because regulations are changing, because there is a scarification of supply, especially automation material, or because simply the customers, they don't want to have the same product as everybody, but they need more customization. So you need to add this flexibility. And to add this flexibility, in fact, you need the use of what we call Industry 4.0 or digital industry or future capabilities which come from the IT. So think about virtual reality, augmented reality, artificial intelligence, for example. All this, you need to link it to your already existing process. And you could do it by adding this layer, which does the orchestration of the already existing process or whatever, and the link as well to the IT sphere. So it's really a double use, not only for greenfield application, but as well for brownfields.
You know, Greg, this has really been a fascinating conversation, and I thank you for really demystifying a relatively arcane and cryptic topic. So thank you for that. Is there, what haven't we touched on that you would like to talk about today?
So, just to make it clear, this association, universalautomation.org, is a non-profit association. It lives from its member and needs to deploy. If you want, as a user, really have this vision come in reality, because we have a few projects which are already starting with that. For example, there is the ExxonMobil test bed, which we go to field trial in a few months, or Shell or Cargill as well, or making some project using the technology. But we want more, and we want to be able to really have an ecosystem of products which are hardware independent. Why? Because when we have this ecosystem which runs, we have more and more developers of software libraries. And those software libraries will help the user of automation go faster and gain more efficiency in the way they do automation. So for example, you want to connect my example back, I want to add an AI to my logistic plan, for example, to check that the boxes are well closed when they go out of the facility. Well, I am not an expert in AI. I'm not an expert with all the AI they are on the market, but I could go to a marketplace and find the right software component which connects to an AI and which does that. But for that ecosystem to be real, we need to develop, and we need for that to have more members. So that's my call a bit to action. Come and join Universal Automation. You're a user of automation, end user, process OEM, machine OEM, or if you are a vendor of automation and you want to expand in that direction, just come and join us.
So Greg, please share your contact information with our vast audience.
So First, if you want to come and contact us, easiest way on the website, so www.universalautomation.org, all in one piece, or you can contact me, greg.boucaud, B-O-U-C-A-U-D, @universalautomation.org.
Again, our guest today has been Greg Boucaud of universalautomation.org. Greg, thanks for joining us today.
Thank you.
And we'll see you on another episode of the Smart City Podcast. Thanks, everybody.
Thank you. See ya.
Broadcasting from Boston, Massachusetts, the Smart Cities Podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter @SmartCityViewpoints or on our website at www.arcweb.com/industries/smart-cities.